All right, so welcome to this section. In this section, we're going to set up the firmware for the drone and also look at how to set up a task using FreeRTOS. And we're going to look at the frequency using the logic analyzer, okay? So to start off, we're going to have a look at this. This is the pin configuration we want to use. And to do that, we'll have to create a new project, okay? So it's loading now. All right, so now we have it, okay? So we want to select the board that we have, or the chip that we have on the black queue. And to do that, we type the STM32 F411, okay? So that is the target for this project. And we select it, so this is it here. And we click on next. So we give the project name QuadFS underscore flight controller. Okay, and this is okay, so we say finish, and this might take some time as well. Okay, so now the project has been created. We can see the microcontroller here, and now we can assign functions to these pins. Okay, so let's start with this. This is the status LED, so we're going to say GPIO out. Okay, and then we can label it as status LED. Okay, so now we go to the motors. So the motors use timer. Okay, so this one will be motor 1, and we select the timer 2, channel 2. Okay, and then we label it as motor 1 or M1. Okay, same with this. This is this will be timer 2, channel 1, and this will be our M0 or M2. Okay. Then this will be timer 1, channel 1 for the M4, motor 4. Okay. Then this channel 1, timer 1, channel 2. Okay, and then we label it as M3. Okay. Nice. So the next thing is the radio receiver. So we're going to have the receiver on the drone, and it's going to make use of UART to receive the data. Okay, so we'll label this as radio underscore RX. And now we go to the IMU. IMU will make use of I2C, clock and data, right? So we use the I2C one, then we label this as IMU underscore STA. And then for the clock, we label this as IMU underscore SCL. Okay, so this is good. Now we can do the configuration here. Okay, let's start with this. Let's start with this, and then we select serial wire. So this is for the debugger. We're going to make use of serial wire. And our time base for this project will be timer 10. Okay, then here the high speed clock, we're going to select crystal. Okay, so this is the external clock. Okay, and now we're going to set up the clock configuration. Okay, so this is the high speed clock. We're going to select it here. Then we want to have 72 megahertz here for these clocks. So what we're going to do is change these factors, and to have 72 megahertz here, the math works out to be for M. We're going to make use of 25. And for this is with 288. Okay, let's see, 288. All right. Okay, and then for this one, is going to be 4, and then we select the input here. Okay, so we have here 72 megahertz. Then for this one, cannot accept 72, so we go to 32 megahertz. Okay, so this would be for the USB, but we haven't enabled that yet. Okay, so go back to the pin configuration. Okay, so the next thing now is the timer. We're going to look at our timer and then assign PWM generation to them. Okay, so you can see. And now we can look at the prescaler. So we want 2 megahertz clock for the timer, and then 400 hertz for the PWM signal. Okay, so that works out to be 35 for this. And then here 4999. Okay, then we enable the auto reload. Okay, so that's all for this. I'll leave this as they are. And then we do the same for the other channel 2. Okay. Okay, let's see. Okay, for the other timer, we select here timer generation 1 for channel 1, then for channel 2. Okay, and then we do the same here as well. Okay, and then for 999, and then we enable the auto reload. Okay, all right. So the next thing we have to check is the I2C for the IMU. So we set it up like this. So we're going to make use of the fast mode, and this is the correct frequency. Okay, and now we look at the UART. So the UART is going to be asynchronous, and then we also want DMA for direct memory access. So the data will be stored directly in memory. So all the input for the pilot will be saved into memory. So this will be a circular buffer, and then the priority here we set as high. Okay. Okay, so that's all for this one. Then the USB. For the USB, we're going to set device only. Then leave this as they are. Go down to the next one. Okay. Okay. Then USB device here as well. Select the virtual ports COM. All right, then we have FreeRTOS. Okay, so we're going to use version 2. Okay, and then we're going to enable the floating point units. Okay, and then here we're going to enable this as well. So this will is needed for printing. Okay, because we're going to be using printf and things like that for telemetry. Then for the clock configuration, since we have added the USB, we have to make this correct. And for this, we're going to make the division here as 6. Okay, now we have it correct. 48 megahertz. Okay, so we have everything ready. And the next thing we're going to do, okay, we can save the project and then generate the code. So to generate the boilerplate code we need. Okay, so Control S, save, yes. Yes. Okay. This might take some time. All right, so now we have everything ready. We can also look at this source file. So we see that we have a main, okay? And we're going to now go into the VS Code so we can have a proper look and then create a tags with the FreeRTOS and then see how we can look at the frequency of these tags, okay? All right, so we are now in VS Code and we can see already the generated code from CubeIDE. And if we look at the main.c, we can also see here the initialization of those components or pins, okay? So this is for the status LED, GPIO, the DMA, I2C, timers for the motors, and then the UART for the radio, okay? So we also have these. This is for the tax scheduler. We're not going to make use of this. So I commented out, some with this, because we are going to make use of our own. So this init hardware. So this is like the entry point of the drone firmware. And if we go into it, we can see that we have, we're launching here tax, and then we start the scheduler, okay? So I've added some files to the project, and this is the QuadFS application .c, .h, and then the dev file. for some definitions, okay? And then this is the task we're going to run in this section, okay? This is the status monitor. Then we have the .h, okay? All right, so let's go back here. And now we can see that I've also added the header file here. And so we can actually just run this code because we have this init.hardware here. So we can go into it and have a look at it. Okay, so here is the status monitor. And here we create the tags. We can go in and see. So we use the FreeRTOS function tags create to create the tags, and this is the function that is going to be running continuously with the status monitor, which you can see here. And here, this is the name of these tags. Okay, then this is the stack size, and this is the priority of these stacks, and this is priority 1 is the lowest priority in this drone project. And here we have the handler. Okay, so let's have a look at the status monitor. Okay, so here we are going to toggle the LED, and to do that we are going to use this function task delay until. Okay, so it takes two parameters or two arguments. So this, the first one here is the last week time, which I've assigned here, the current one before the forever loop. Okay, so this is the current count, and we assign it here, and then we assign here how long we should wait. Okay, and then it waits until this time has elapsed, and then it implements or updates this parameter. Okay, so let's see what this is. So this is the task tick time. The tick time for the FreeRTOS setup we have is 1 tick is 1 millisecond. Okay, so if we have 20 here, so this is 20 milliseconds, which is 20 ticks. Okay, and this works out to be 50 heads. Okay, for this task. So this task will run at 50 heads. Okay, and priority 1. So when we have higher order tasks like controller and let's say the telemetry, they can preempt these tasks and then stop these tasks from running and then perform their own tasks. But for now, we're just going to look at the frequency. All right. So this is a 50 hertz task. But if we look at the logic analyzer, we'll see that the frequency of this toggling will be 25 hertz because we'll have an off time and an on time. Okay. So if we look at the logic analyzer now, we can see for now. Okay, so for now everything is low. Okay, and you can see as well that the LED doesn't blink. Okay, so the next thing we are going to do now, we can go back here and then go to the Cube IDE. Let's see, in the Cube IDE, we can run the project and then flash it. So this is my debugger, and here is my logic analyzer connected to the LED. Okay. Okay. But before we flash it, I just want to mention an important point for the radio. So we're going to make use of this baud rate here. So this is very important, okay, since we're using the eyeballs. Okay. Okay. So now to flash the project, we just click on this. So to build and then flash the chip on the black pure. Okay. Here. All right. So finish without any errors. Now wait for it to flash. Okay, yeah, we can switch. Yes, yes. Okay, now we click on resume. So before we do that, we can maybe have this here, then resume. Okay, we can already see the LED is blinking, and if we have a look at this, we can already see, okay, we have the PWM signals here. Okay, so I will pause this so that we can have a look. Okay, so we can see the 20 milliseconds for high and 20 milliseconds for low. Okay, so that works out to be 25 hertz for the frequency of the blinking, right? But for the task itself, which is the width of one event, this is 50 hertz. Okay, so we have it now running. Okay, So with this, we can say, okay, that we have the right frequency for our FreeRTOS stacks, okay? Now let's go back to the VS Code, okay? So this is how we are going to create the tags for other components like the controller and then telemetry, okay? So the next section, we're going to have a look at how to set up the timer for the motors, and also look at the IMU creation, I2C, and other peripherals, okay? So see you in the next section.